channel of BYJU'S Exam Prep. And welcome back once again in last lap to CMAT 2023. Now friends, today we are going to take on geometry and mensuration as a topic. And as far as the QA section is concerned, geometry mensuration, not a very important topic, but definitely you can find somewhere around 3 to 4 questions from this area combined. So geometry and mensuration. So friends, welcome back, all of you. I hope you are on a proper direction. You are moving in a proper direction as far as your preparation for CMAT examination is concerned. The examination is, I can say, around 1 week from now. And yes, we have very less number of days left for this examination. And in these last days, it becomes very important to revise, to give, let's say, 2 or 3 hours to each and every topic so that you have all those formulas in your mind. You can recall all the concepts. There are plenty of concepts that we have in geometry and mensuration. So today this session is specially conducted for all of you so that we can go through some of the important formulas about geometry and mensuration. All right. So friends, welcome back once again. Mr. Anu, good afternoon. Good afternoon, everyone. Good afternoon, all of you. So, last lap to CMAT 2023, this series, it has already started, like it started a few days back. And I believe all of you are attending sessions regularly in this series of sessions. So, geometry mensuration, first of all, let us understand the weightage or the importance of this area in CMAT examination, right? Now, it is an important topic. Yes, we can say that because every year we have seen at least 2 or 3 questions coming from this area. So the area which is present every time in CMAT examination, we can call it an important area. Without fail, you will find 2, 3 questions from geometry as well as mensuration in every year. Okay. Now, talking about the areas that comes under geometry and mensuration. So lines and angles, polygons, triangles, circles, quadrilaterals, and then the solids, the three-dimensional figures. So which is based on, so in solids, you can see the questions which are based on finding the area, surface area, volume, and so on and so forth. So all these are questions based on solids, right? Now, in this session, I'll be taking you through some of the important formulas which are related to geometry, and then we will solve some of the questions. Now, intentionally, I have kept the level of difficulty on slightly on a higher side. Basically, I have tried to incorporate more than one logic in any of these questions. So through these questions, probably we'll be taking on lesser number of questions, but we will be taking on more number of concepts. So all these questions will be application based. In some cases, you will get to know some of the new formulas based on geometry and mensuration, which you might know earlier, which you might not know earlier. Okay, so just focus on this lecture, and wherever you want, you can make your notes. Okay. Sir, what type of question can come in CMAT? So, Kushagra, if you are asking about geometry and mensuration specifically, so I can say that whatever questions I have seen coming up in previous years, the level of difficulty is moderate. Okay. So, most of the questions are based on direct formulas, but sometimes I've seen questions which are based on applications, the concepts as well. Okay. Pratik, you're asking, sir, what about food and agribusiness management? So, Pratik, what do you want to know about that? Obviously, right now, I'll not talk about food and agribusiness management. So, you can read it over, read about it over the internet. But today, it's not the right time to discuss about food and agribusiness management. Please guide for any practice source for DILR questions. Now, Prajwal, there are plenty of books in the market, but plenty of books. I cannot name one book over this portal. Okay, that will be unfair. But we at BYJU'S Exam Prep also offer study material for the preparation of DILR. So you can pick up any of these things. The only thing that you must take care is the level of difficulty that comes in CMAT. Okay, so what you can do is initially, अब तो time नहीं बचा है तुम्हारे पास. It's less than 1 week. But what you can do is you can quickly get some DLR book from the market, taking care about the level of difficulty of this examination. All right, chaliye. So let's not waste any further time and talk about some of the important formulas related to this area. I'll start from lines and angles, and two of the most important things, like which sometimes we forget, is about complementary and supplementary angles. I cannot cover the entire theory of geometry and mensuration. Okay, it will require 3 to 4 hours definitely, but I'll cover up some of the important pointers that I feel you all need to brush up. Okay, now two angles are said to be complementary when their sum is 90 degrees, and two angles are said to be supplementary if their sum is 180 degrees. Okay, so I'll take an example. So let's say there is an angle which is 40 degrees. Now complementary of this angle, so complement angle of 40 degrees will be 90 minus 40, that is 50 degrees. So 50 degrees is the complement of 40 degrees. Similarly, if I am looking for supplement of 40 degrees, so you will subtract it from 180. So 180 minus 40 is 140. So 140 is the supplement of 40-degree angle. All right. Now moving ahead, the next thing is about the formulas for the areas of triangles. Okay. Now first formula is for scalene triangle. Not necessarily this is applicable for scalene triangle, but this formula is applicable whenever you know all the three sides of a triangle. Okay. In that case, you can use Heron's formula, and the formula is under root of s into s minus a into s minus b into s minus c, where S is called the semi-perimeter of the triangle. It is equal to the sum of the sides divided by 2. Semi-perimeter, that means half of the perimeter, where A, B, and C are the sides of the triangle. Okay, so this is one formula that can be used provided all the three sides are given, right? Now the second formula is for the equilateral triangle when all the three sides are equal. So you can directly use this formula. Now it is very important to remember the formula for equilateral triangle. Okay, so it is root 3 upon 4 side square. So in this formula, A is the side of the triangle. So directly you can remember and use this formula for equilateral triangles. All right. Okay. Now moving ahead and looking at the other formulas. So the third formula is or can be used whenever you are given any two sides of the triangle and the angle that is included between these two sides. For example, let's say this is a triangle, and this side, two sides are given. Let's say one of the sides is A and the other side is B. Now the angle that will require to find out the area of this triangle will be the angle which is included between these two sides. So the angle that I've marked in the figure, this is the angle that will be required. Okay. So the formula for area of the triangle using the two sides and the included angle will be half the product of sides multiplied by the sine of containing angle, a little bit of trigonometry. Okay, so half AB sine theta will be the area of this triangle. All right, so that was formula number 3. Now moving ahead and looking at the next formula. Our next formula is applicable for a right angle triangle, or in case in a triangle the base and the height is given. Okay, so I'll take an example. So look at the triangle that I'm drawing at the bottom of the screen. So ABC is a triangle. Now if I'll consider BC as the base, if BC is the base, okay, then the height of this triangle will be the perpendicular drop from vertex A on side BC. So vertex A से BC पर एक perpendicular drop कर दो. Let's say it is meeting at point D. So AD will become the height of this triangle. All right. So the area of triangle will be equal to half into base into height. All right, where height is the perpendicular to the base. So in a right angled triangle, you can say that the area will be half multiplied by the product of the two perpendicular sides. Okay, so this formula can be applied whenever the sides are perpendicular or you are given the height and the base of the triangle, right? Now let's move ahead and look at some of the important relations that can be derived directly in right angled triangles. Now, if you remember these two things that I'm going to tell you in the next 2 or 3 minutes, you can save 20 to 30 seconds while calculating the different sides of a right angled triangle. Look at the case number one, a right angle triangle in which the angles are 30, 60 and 90 degrees. Okay, so I'll give you an example for this. So let's consider this right angled triangle ABC, which is right angled at B, and it is given that angle C is 30 degrees. So if angle C is 30 degrees, then angle A will be equal to 60 degrees. All right. Now, directly you can say that the ratio of the sides opposite to 30-degree angle, 60-degree angle and 90-degree angle. You can write the ratio of the sides which are opposite to 30-degree angle, that means AB, opposite to 60-degree angle, which is BC, and opposite to 90-degree angle, which is AC. So the ratio of these three sides will be equal to 1 is to under root 3 is to 2. Okay. So if any one of the three sides is given in a 30, 60, 90-degree triangle, then you can easily write, you can quickly write the length of the other two sides. For example, let's say I am given AC, I am given the hypotenuse, let's say it is given as 10. Okay, so if the side opposite to 90 degrees is 2, then side opposite to 30 degrees will be 1, that means half of this. So in this case, AB will become 5. All right. Now, once we have obtained AB, then BC is root 3 times AB. So it will be 5 under root 3. Okay. So this particular thing can be done directly, right? So this is for 30, 60, 90-degree triangle, right? Now the next triangle is 45, 45 and 90-degree triangle. Now 45, 45, that means it will be an isosceles triangle. So two of the angles are 45 degrees. So the sides opposite to equal angles will be equal, and one of the angles is 90 degrees. Now the ratio of the sides which are opposite to 45 degree, 45 degree and 90 degree angle will be 1 is to 1 is to root 2. So you can use this particular relation exactly in the similar manner the way I have explained you the previous case. Okay, so just remember this particular rule and it will guarantee you to save 20, 25, 30 seconds in any of the questions in which these two types of triangles are used. Okay, चलिए आगे चलते हैं and look at the next thing. Now the next thing is about a right angled triangle. Now these two rules that I'm going to tell you now will be applicable only for a right angled triangle. Now there are some questions which will ask you to calculate the in radius or the circumradius of a right angled triangle. Now in radius can directly be calculated using this formula, a plus b minus c divided by 2. Now what are a, b and c? In a right angle triangle, here C is the largest side or the hypotenuse. Okay, hypotenuse is the largest side. So C is the hypotenuse and A and B are the other two sides. Okay, right? In this formula, looking at this formula, A and B are added and C is subtracted. So you need to separate C from A and B. Okay, so the formula is A plus B minus C upon 2, where C is the hypotenuse and A and B are the other two sides. Right? Next thing is the circumradius, a very, very important rule. So I'll draw a right angle triangle. A, B, C, right angled at B. Okay. Now in a right angled triangle, circumcenter, first of all, I'm talking about circumcenter. Circumcenter is always the midpoint of hypotenuse. Okay. Circumcenter, I'll write it. Circumcenter is always the midpoint of hypotenuse, right? So AC is the hypotenuse. The midpoint of this will be the circumcenter. Let's say this is O. Okay. Now in this case, this circumcenter, it's a property of any general triangle that circumcenter is always equidistant from the three vertices. So this point O is equidistant from A, C, and B. So if I'll join OB, so OA is equal to OB is equal to OC, and all three of them are equal to the circumradius of this triangle. Okay, so you can say that the circumradius of a right angled triangle will always be hypotenuse divided by 2. Hypotenuse divided by 2. All right. So Inradius and circumradius for a right angled triangle, these are the direct formulas. Now you all can keep noting down all these things. It will definitely help you in the examination. चलिए आगे चलते हैं. Now some of the formulas related to the polygons. Polygons directly ये वाले formulae बहुत important हैं because I've seen instances where these formulas are used directly. So they will give you questions which are directly based on these formulas. Formula apply करो, answer पता लग जाएगा. Okay. Now, first of all, a random convex polygon. So sum of all the interior angles of any convex polygon is n minus 2 into 180. यहाँ 1800 नहीं है, this is 180. This is degree. छोटा सा गड़बड़ हो गई. So yes, Mr. Anu, that has happened way back. So it is already happened. So the sum of the interior angles will be n minus 2 into 180, where n is the number of sides. Okay. So if a convex polygon has 7 sides, then the sum of all interior angles will be 7 minus 2, that is 5. 5 into 180. Now this will come out to be 900. Okay. This is the first formula. Now look at the third formula. Sum of all the exterior angles of a convex polygon. So take any random convex polygon. The sum of all the exterior angles will always be 360 degrees, and it will never depend on the number of sides. Whatever be the number of sides, the sum of all the exterior angles, will be equal to 360 degrees. Right? Okay. Now next is formula number 5. Number of diagonals in a convex polygon. You will wonder why I've left the other two formula, because the other two formulas are specifically for regular polygons. Okay, so I'll come back to formula number 2 and formula number 4, but formula number 1, 3, and 5 are applicable for every convex polygon. Okay, so number of diagonals in any convex polygon is equal to n into n minus 3 divided by 2. Where n is the number of sides of the polygon. Okay, so again, if the number of sides is 7, then the number of diagonals will be 7 into 7 minus 3 is 4 divided by 2. All right, so that will come out to be 14. So 14 will be the number of diagonals if the number of sides is 7. All right, so that was formula number 1, 3, and 5, which is applicable for every polygon, every convex polygon. Now looking at formula number 2 and formula number 4, which are specifically for regular polygons, regular convex polygons. Now regular polygon means all the sides as well as interior angles will be equal. So all sides and all angles will be equal. Okay? So that is called a regular convex polygon. Now, first of all, we'll find out the measure of each angle. So the measure of each angle will be the sum of all angles, which was formula number 1, divided by the number of sides or the number of angles. So sum of all the angles will be equally divided among all the angles. So that is why the first formula divided by n. Okay. Next, formula number 4, each exterior angle. So obviously all the exterior angles will also be equal. So sum of all exterior angles is 360 degrees. Each exterior angle in a regular polygon will be 360 divided by n. Okay, so the third formula divided by n is the fourth formula. All right, so these are the formulas for the polygons. Now moving ahead and talking about some of the properties related to the circles. Property number 1 related to chords. The perpendicular distance from the center to a chord will bisect the chord. So in a circle, if you will drop a perpendicular from the center of the circle to the chord, then this point which is the foot of the perpendicular, it will divide the chord in 2 equal parts. and the converse of this property is also true. All right, this is formula number one or property number one. Now, property number two is the angle subtended by a chord at the center is double the angle it subtends at the circumference. So, I'll draw the figure for you. This is a very common property. Now, let's say AB is the chord or the arc. The angle subtended by this arc AB at the center of the circle is double the angle subtended by the same arc on the other side of the circle. So if this angle is theta, the angle at the center of the circle will be twice of theta. That is property number two. Property number three is angle in a semicircle is always a right angle. So in a circle, if I draw the diameter will divide the circle in two parts. So the angle made by the diameter on the circumference of the circle will always be 90 degrees. So this angle will always be a right angle, right? So this is the property related to chords. Let's move ahead and look at some other general property related to circles. Now next property is property related to tangents. Property number one, किसी भी external point से, like if you will draw a circle from external point, there can be two tangents which can be drawn to a circle. Outside point से दो tangents बन सकती हैं and the length of these two tangents will always be equal. Okay, these two tangents will be of equal length. So from point outside the circle, we can draw two tangents to a circle which will be of equal lengths. Next is, if you draw a tangent to a circle like this, then at this point, if you join it with the center of the circle, so the radius and the tangent will make an angle of 90 degrees between them. So if a straight line is drawn as a tangent to a circle, the radius drawn to this point of contact will be perpendicular to the tangent. A very simple, a very basic property related to circles. ठीक है, चले आगे. Next property, from an outside point, एक tangent draw किया मैंने PT. So PT is the tangent touching the circle at point T. And PAB is a secant. Secant क्या होता है? Outside point से एक line draw करेंगे, which will intersect the circle at 2 points. Okay. So PAB is a secant. So according to the property, it says that length PA multiplied by PB will always be equal to PT square. Again, this is a very common property as far as tangent and secants is concerned. PT square is equal to PA into PB. All right. Let's move ahead and look at some of the questions now. So all of you now be ready to practice some questions. Now these questions might be slightly difficult. So what I'll do is I'll give you 1 minute for every question so that you can be comfortable, you can understand that question, you can read the information that is given, and then we'll start with the discussion of that question without waiting much. Okay, so jaldi jaldi hum in questions ko dekhte hain, and whatever concepts that I'll be telling you, please make a note of these concepts. You might get to use these concepts at the time of examination. ठीक है ना? चलिए. So question number 1 on your screen now. Find the difference between the inradius and the circumradius in a triangle whose sides have lengths of 9, 10, and 17. Now, using this question, you will get to know two more formulas of finding the area of a triangle. Come on, read this question, try to understand, and in case you can find the answer, you can do that. Obviously, there is no one who is stopping you. So try to find the answer, but after a minute, I will start explaining you the logic or the concept behind this question. Now, like I told you, I've tried to incorporate more than one or two logics, more than two logics in every question. So using one question. You might not get this lengthy question in the examination probably, but my agenda is to cover up as many concepts as possible. Okay, so a small part of whatever I'll be explaining you in every question might be used as a separate question in the examination. Okay, चलिए start करते हैं. Now, the three sides of the triangle are given. Now, first is I'll find out the area of this triangle. Okay, I'll find out the area of this triangle using these three sides. Now, if three sides are given, the perimeter of this triangle is 9 plus 10 plus 17, that is 36. So, the semi-perimeter will be 36 upon 2, that is 18. Okay, so area will be, I'll use Heron's formula, under root of S into S minus 9, 18 minus 9 is 9, then S minus 10, that is 8, into S minus 17, 18 minus 17 is 1. Okay, so let's write the area 9 into 4. So I'll remove this under root sign, directly लिख देते हैं. So 36 will be the area of this triangle. Okay, 36 will be the area of this triangle. Now, to find out the area, there are two more formulas which are in the form of Inradius and circumradius. So area of a triangle can also be written as small r into small s. Also, it can be written as ABC upon 4 capital R. Okay. Now, in this formula, in the first formula, small r is the Inradius and small s, we already know that this is semi-perimeter. In the second formula, capital R is the circumradius and A, B and C are the three sides of the triangle. Okay? Now we already have area, that is 36. Now I'll use the first formula to equate the area, and from there I'll get the value of small r. Okay? So we already know that area is equal to 36 and small s is equal to 18. Okay, so area is equal to small r into small s, and small r will be equal to area upon s, that is equal to 36 upon 18 equal to 2. So I have got the value of Inradius. Done. Keep it aside, and then now I'm using the formula area is equal to ABC upon 4 capital R. So capital R will be equal to ABC upon 4 area. Now A is 9, B is 10 and C is 17, the three sides, divided by 4 multiplied by 36. Okay, so 9 and 36, यहाँ पे 4 आ जाएगा, 10 will become 5 and 4 will become 2. So this value will become 85 divided by 2. Okay. Now we have to find out the difference between the Inradius and circumradius. So the difference between these two numbers, 85 upon 2. Oh, sorry, 85 upon 8 होना चाहिए वो. Small mistake. Okay. A small error. So 85 upon 8 minus 2 will be equal to 69 upon 8. So 69 upon 8, Mayank has given a correct answer. Good, Mayank. Okay. Now guys, अब ये चीज समझो, इतना lengthy question नहीं आएगा, but using this question, I have seen three things. One is finding the area of the triangle using Heron's formula. Second is finding the area of the triangle using Inradius, and the third is using circumradius. Okay, so एक साथ, like simultaneously, three of the formulas for area of the triangles were used in a single question. That is good for your understanding. Okay, so keep this in mind. So the correct answer is 69 upon 8. Question number 1 is over. Let's move on to the second question. All of you, focus now. Second question. In an equilateral triangle ABC, D and E are on BC such that BD is to DE is to EC is 1 is to 1 is to 1. Find the ratio of AB and AD. A good question this one is. Again, I'll give you 1 minute. You can draw the figure, okay, and you can mark the points. You can write the length of each of the sides. You can start by assuming the length of each side of this equilateral triangle, okay. Okay, so let's start drawing the figure of this question. Equilateral triangle, I'll quickly draw one, okay. Now I'll start by assuming the length of each side of this equilateral triangle. I'll assume each side as 6. You will understand why I have assumed each side as 6. Okay. So each of the three sides is 6. Now B and E are the points on BC such that they are equidistant from each other. So this is 2, 2 and 2. Okay. Right. Now we have to find out the length of AD. Length of AD calculate करना है. Length of AB is already known, right? Now to find out the length of AD, I'll join A and D, okay? And we'll drop a perpendicular from A on DE, okay? I'll drop a perpendicular here. So if I drop a perpendicular, it will be the midpoint. It will be the midpoint of BC, right? Let's say this point is F. So here BF will be equal to 6 divided by 2, that is 3. So DF will be equal to 1. All right. So the length of DF will be equal to 1. Now length of AF, which is the height of this triangle, you can note down the direct formula for this. Length of AF, that is the height of height of an equilateral triangle, is equal to root 3 upon 2 into the side. Okay. So that will be equal to root 3 upon 2 multiplied by 6. That is 3 root 3. So AF is equal to 3 root 3 and DF is equal to 1. Using Pythagoras theorem, I can find out the length of AD, which is equal to under root of AF square plus DF square. So under root of AF square, that is 27 plus 1, 28. And this will be equal to 2 under root 7. Clear? ठीक है? So AB upon AD, which is required, is 6 upon 2 root 7. That is 3 upon root 7. So 3 upon root 7, that is option B is the correct answer. Okay? Option B is the correct answer. Am I clear? So the correct answer is 3 under root 7. Prajwal has given the answer. Mayank has given the answer. So 2 students who have given a correct answer. Nice. Let's move on to question number 3. Find the volume of the cuboid. Interesting question. थोड़ा सा tough है. ठीक है, मैंने जान के इसको tough बनाया है. Find the volume of the cuboid if the longest rod which is fixed into it is of length 17 centimeter. The width of the cuboid is 25% less than the length, and length is 50%, sorry, length is 150% of the height. Yes, question 6, I have assumed to make the calculations easy in the previous question. Calculations थोड़ी सी easy हो गई थी अगर मैंने 6 उसको assume किया. Because 6 can be divided by 2 as well as 3. That is why I have assumed the length of each side as 6. Yes, anyone with the answer? All right, चलिए start करते हैं. Let's start with the discussion of this. Okay, now find the volume of the cuboid. Length of the longest rod is given as 17. Now the length of the longest rod, the formula for this is under root of L square plus B square plus H square. Okay. But length, breadth and height are not given, but the relation between them is given. Length, breadth and height. Now, first of all, the length is 150 percentage of the height. I'll start by assuming height as 8x. So the length will be 150% of the height, that will be 12x. And the width is 25% less than the length. So this will be width or breadth will be 9x. So again, I've started by assuming height as 8x. Okay? Okay. Now, the length of the longest rod will be under root of L square, that is 144x square, plus B square, that is 81x square, plus H square, that is 64x square. And this is given as 17. From here, we can find out the value of x. So I'll take x common. It will come outside the under root. 144 plus 81 plus 64. So let's add all of them. 14, 22, 26, 260, 289. 289 under root is equal to 17. So under root of 289 is 17. So the value of x will come out to be 1. And hence, I can say that the length will be equal to 12, breadth will be equal to 9, and height will be equal to 8. We have to find out the volume of this cuboid. It will be 12 into 9 into 8. Okay. Now 12 into 9 is 108 into 8. That is 864. So 864, that is option D will be the correct answer. All right. Fine. Let's move ahead and look at the next question, question number 4. Question number 4 is again an interesting question. An equilateral triangle ABC is drawn and BC is the tangent to the circle at point D. So the side BC of the triangle is acting as a tangent of the circle and it is touching it at point D. And A, the point A, the vertex A of the triangle is on the circle's circumference. तो वो circle की circumference है. So circle point A से pass कर रहा है and it is tangent to BC. AB cuts the circle at P. So find the ratio AB is to PB. Any answer for this? Okay, okay, all right. चलिए, important is to draw the figure. Figure clear होना चाहिए. Then only you will be able to get a correct answer for this one. An equilateral triangle. So first of all, drawing an equilateral triangle A, B, C. Okay. Now I have to draw a circle such that it is passing through point A and it is tangent to BC. Okay. So BC is the tangent. So I can draw a circle like this. Okay. I can draw a circle like this. Wait, I'll draw it again. So it should be clear. Please pardon my drawing. All right. Perfect now. Okay. So I'll draw a circle like this. It is tangent to BC at point D. Now, one important thing is this point D will be the midpoint of BC. All right. Also, this circle is passing through AB and cutting at point P. And we have to find the ratio of AB and PB. Now, today only, just before starting the questions, I have told you one property which is related to the tangent and the secant of a circle. Okay. So here I'll start by assuming that BD is equal to 1. So BD is 1, CD will also be 1. So basically I have assumed that the side of this triangle is equal to 2. Okay. So side of this triangle is 2. D is the midpoint. So both will become 1 and 1. BD and CD. Done. Also AB will be equal to 2. AB is the side of this triangle will be equal to 2. BD is equal to 1. Now using the property, I can say that BD square will be equal to BP multiplied by BA. BD square will be equal to BP multiplied by BA. BD I already know, which is 1. So 1 square is 1 equal to BP multiplied by BA is 2. So the length of BP will be equal to 1 upon 2. All right. Length of BP is equal to 1 upon 2. Now the ratio AB upon PB. So AB is already equal to 2, right? And divided by BP or PB, that is equal to half. So this ratio will come out to be 4:1. So 4:1 will be the final answer for this question. And the correct answer is option B, which is given by Mayank, Mr. Anu, Kaushal, and Jyoti. 4 people have given a correct answer. Nice, good. So yes, 4:1 is the correct answer. Next question, question number 5. Now this is an easy one. इतना difficult question नहीं है. I'm expecting an answer of this question from majority of you. If a cone is cut parallel to its base at 2/3 of its height from the ground, then find the ratio of the volume of the smaller cone to the original cone. Quickly. Okay, Rama. फाइन. चलिए स्टार्ट करते हैं. क्वेश्चन बहुत इजी है. दैट इज व्हाई आई एम नॉट गिविंग यू अ लॉट ऑफ टाइम. So first of all, I'll draw a bigger cone. Okay. Now let's assume that the height of this cone is 3. Okay. Why I've assumed height as 3? Because the cut is applied at 2/3 of the height. Okay. 2/3, that means height should be divisible by 3. That is why I've assumed it as 3. Done. Now at 2/3 of the height from the ground. Now 2/3 of 3 is 2. So at a height of 2 from the ground, a cut is applied on this cone, something like this. Okay. So now the height of the new cone, the height of the smaller cone will be equal to 1, right? So height of the smaller cone is 1 and height of the bigger cone is 3, right? Now, whatever be the radius of bigger cone, the radius of smaller cone will also be 1/3 of the radius of bigger cone. So I can say that all the 3 dimensions of these two cones, the smaller cone and the bigger cone, okay, so all the dimensions, all the lengths are in the ratio 1:3. Okay, so the ratio of the lengths, that is the height or the radius or the slant height, will be 1:3. Now, these 1:3 is the ratio of the lengths, right? Now, the ratio of the areas, curved surface area, total surface area, or whatever it will be the square of the ratio of the lengths. So 1:3 ka square ho jayega. That is 1:9. This is the ratio of the areas. Now, if they're talking about the ratio of the volumes, so it will be the cube of the ratio of the sides. Okay, so 1:3 whole cube, that is 1:27. So the ratio of the volume of the smaller cone to the original cone will be equal to 1:27. That is option B. Okay, let's move on and look at question number 6. Now, question number 6 is a good conceptual question. Now, AB and CD are the parallel sides of the trapezium and the ratio is given as 1:2. Okay? The area of the triangle AOB is 50, where O is the intersection point of the diagonals. You'll have to find out the area of the entire trapezium. Find the area of the entire trapezium. Now you will get to know 2 more concepts using this question. Alright, Kaushal has given the answer as option C, which is 400. Okay, nice. But let's see if this is correct or not. Okay, so let's start with this. First of all, let us draw the figure. So I'll draw a trapezium. The sides are A, B, C, and D. Now the ratio of the length of the sides of AB and CD is 1:2. So I'll assume this as X and this as 2X. Also, the diagonals intersect at point O. So this is point O. Okay. Now the area of triangle AOB is given as 50. Now let's take it one by one. Now first of all, I'll consider triangle AOB and triangle COD. Okay. Now in a trapezium, these two triangles are always similar. Okay. Why? Because this angle and this angle, they are equal. They are vertically opposite angles. this angle B of the smaller triangle is equal to this angle of the bigger triangle, and the third angle, angle A, will also be equal to this angle C. So we can say that triangle AOB will be similar to triangle COD. Okay. Now the triangles are similar. I can write the ratio of their sides. So 1:2, the ratio is already given. So the ratio of the sides is 1:2. Now if the ratio of the sides is 1:2, the ratio of areas will be the square of this. That is 1:4. Okay, number one. So ratio of areas पता लग गया इन दोनों का. So area of the smaller triangle is 50. So the area of the bigger triangle will be 4 times 50. That is 200. Okay. So area of triangle COD is equal to 200. This is point number one. Clear? Okay. Now next is the area of the remaining portions. So the area of this portion, let's say it is K. So the area of the other triangle will also be K. So in a trapezium, the area of these two is always equal. Okay. And the area, the value of K is always the geometric mean. The geometric mean of these two areas. Geometric mean of 50 and 200. It is always there. So the area of this triangle AOD is always the geometric mean of the area of triangles AOB and COD. So this will come out to be 100. So the value of K is 100 and 100. So now you can add up all these values and get the total area of this trapezium. So total area of this trapezium will be option B, that is 450 square units. Okay. All right. Are you understanding these concepts? Now these questions, if you remember these concepts, if you know these concepts, then these questions will become very easy for all of you. Let's move on and look at question number 7. Question 7 easy question hai, zyada difficult nahi hai. You must do it. You can do it in less than 1 minute. A square is formed by joining the midpoints of the sides of another square. The same procedure is repeated to form another square. If the process is followed to form infinite squares, then we'll have to find out the sum of the areas of all the squares if the area of the largest square is 8 units. All right, Mayank, nice. Now, if you catch the logic that will be applied here, you can get the answer in less than 30 seconds. So if I draw one square and then another square which is formed by joining the midpoints of this square. So let's draw the another square. What is the relation between the areas of these two squares? Come on. So you can see a yellow colored square and a green colored square. So obviously the area of green colored square will be less than that of yellow, but what is the relation between them? Okay, so you can see that the ratio, or if the area of yellow colored square is 8, then the area of green colored square will be 8 upon 2. So whenever you will draw a square formed by joining the midpoints of another square, then the area is reduced by half. Area half ho jayega. Okay. So every time the area will keep on dividing by 2. So originally the area was 8. The area of second square will be 8 upon 2. The area of third square will be further divided by 2. That means 8 upon 4. Then 8 upon 8. Then 8 upon 16 and so on. So what is this? This is a geometric progression, right? This is the GP and this is an infinite GP. Now, sum of all the terms of an infinite GP is A upon 1 minus R. Now, in this case, A is 8 and the common ratio is 1 upon 2. So you can find out the sum of this infinity. 8 divided by 1 minus 1 upon 2, that will come out to be 16. So so 16 will be the sum of the areas of all these squares in this figure. Okay, fine. So you just need to understand the relation between the original square and the first square, and you will get the answer of this one. Let's move ahead and look at the next question, question number 8. Find the volume of the cylinder with radius 7 and height is twice as much as the radius. So radius is given, you can find out the height and hence the volume of this cylinder, provided you must know the formula of the volume of cylinder. All right. Simple question है, ज़्यादा difficult नहीं है. You just need to directly apply the formula. चलिए देखते हैं. Now the volume of cylinder is pi r square h. In your calculations, you can take the value of pi as 22 upon 7. Okay. Now pi, that is 22 upon 7 multiplied by radius square, that is 7 square multiplied by the height. Now height is twice as much the radius, so height will be equal to 14. I just have to simplify 22 into 49 into 2. That is 44 into 49. Let's simplify this. 36, 6, 3, 36 and 16, 52, 55 and 5, 21. So 2156. 2156. Yes, it is option A, correctly given by Mayank, Aditya, Jyoti, and Kaushal. All of you. Nice. So option A will be the correct answer for this question. All right. So friends, that is all about today's lecture. So I had the theory and these 8 questions for all of you. I hope you would have learned something new out of this session. Okay. Now this is the schedule of the upcoming sessions. Now today it's 26th of April. So 26th of April at 7 p.m. you can have this session, and then 27th and 28th April. So this is the schedule for the next 2 days. All right. Now, don't forget to join us on 4th of May for the live analysis of CMAT 2023. Okay, so 4th of May, you will be communicated the exact time for this, but please do join us for the live analysis of CMAT. Now, the students who are preparing for CAT 2023, if they want to join any of the comprehensive programs at BYJU'S Exam Prep, so on your screen, you can find the details of this entire program. Also, you can look at the link that is given in the description of the session to have an inquiry about this program. You can follow us on these social media platforms. Thank you to all of you for being a part of this session. We'll see you once again. Have a wonderful time.